Hey everyone, welcome back. Today we're going to be going over to Profili Pro 2, which is the software that we use to generate the geometry for our lifting surfaces. So for your wings, for your tail, for rudder, things like that. What we're going to do is on the computer, click on this icon, which is Profili Pro 2. It is the one that's shaped like an airfoil with a pencil on it. We'll open up our program here. Sometimes they'll come up with a little hint at the beginning, you can just close out of those. There's a lot of capabilities that are built into this software. What we're going to primarily use this for is for cutting a foam panel on the foam cutters. So we go up to Panels, Wing Panels Management. You're going to see a list of wing panels that have been created in the past. So you're going to want to create your own by clicking on Panels Management, New Foam Panel for 4-axis CNC hot wire cutting. Most mouth-worthy one is the one that we're going to be using. Once you come in here, the first panel is going to have you just lay out the general geometry for this. So I should preface all this by saying that before you come to Profili Pro, you should have all the geometry laid out for how you want to be sizing everything. You should know what airfoil you want to be using, what your cord lengths will be, what your span will be, any sweep or washout, any geometry like that. Additionally, you need to be able to kind of take a look at the foam cutters to know how wide they are, the size of your foam block that you'll be cutting your airfoil out of, things like that. So all that will become evident as we go through this video here, so stay tuned. We're going to start out by creating a panel name. This will be the name that we see on the list that we saw previously. I'm going to go ahead in here and call it something descriptive. Let's say ME415, TA, test, so my name essentially, and what kind of airfoil I'm cutting, because you're going to be creating multiple of these. So for this test, I'm going to be creating a pseudo elevator, a horizontal stabilizer. So I'm going to do H for horizontal and tail for horizontal tail. If I want, I can add a description in right here that will give me more information as to what it is. If I want, I can throw in all of my parameters that I'm going to be using here in the description, whatever you find most useful with that. Keep in mind that the units for all of this and for the foam cutters themselves will be in millimeters. So it's okay to do all of your analysis in inches or whatever base unit that you prefer or your team prefers, but know that once you get to Profili and to Mach 3 for cutting out your wings, you will need to convert everything to millimeters. So using millimeters, I have a half span for my wing of 292.1 millimeters. My root cord is going to be 200 millimeters, tip cord 100 millimeters, and if I want at this point, I can just hit apply to see what that's going to do. And that'll update the screen down here as a preview of what my wing is going to look like. I actually want my trailing edge to be flush and flat, so I made an error here. It's going to be 150 on this guy. And you see that I have my leading edge swept back a distance right here of 25 millimeters, as I've said right there. I actually want that, increase that to 50 millimeters, and hit apply again, so that my trailing edge is just flat. That's a personal preference of my pseudo design choice. You can have whatever taper ratios or sweeps that you want. Just make sure, again, to come prepared for those. If I wanted to come with a twist on my wing, I could add a root incidence angle and a tip incidence angle. Whatever your washout is going to be will need to be the difference between these two values. So you can go ahead and check that on later slides to make sure that you've input the correct angles there. But for my case, where I'm just doing a horizontal stabilizer, I'll keep those at 0. Moving on to the next screen, this is where you choose your airfoil. Keep in mind that the foam cutters cut using a straight hot wire from root to tip of your section. So you can have different airfoils at both your root and at your tip. However, it'll create some sort of weird hybrid between those two airfoils as you travel from the root to the tip of your airfoil. It'll be a direct loft between the two, where you have no control over that loft other than it being a straight line. So typically it is best practice to have the same airfoil for both your root and your tip, but you can play around with that if you feel so inclined. I should also notice here that although wing twist will also change your airfoil slightly in the middle, as long as you have the same airfoil for both your root and your tip, and you have a reasonable washout of only a few degrees, then the effect in the middle of your panel should not be significant. So as we do the drop down here, we notice that we have plenty of airfoils loaded into the system. You can go and load in your own airfoil if you have some sort of custom airfoil if you want, but check here first. We most likely have the airfoil that you're looking for. It's very rare that someone comes up with a unique one unless you built it yourself you want to implement. For my horizontal tail, I'm going for a symmetrical airfoil. So I'm going to choose the NACA 0012. So I can see it update there on my root. If I look at my tip though, I have my original airfoil of this 12% Jukowski. I'm going to make sure to select this one as well. And now I can go back and forth between my root and my tip and see that both of those airfoils are the same. Go to my wing plan, it should be the same as it was before. You only have these three views as you move forward, so be sure to toggle between all three of them so you get a good idea of what your wing is doing. You don't get any three-dimensional views with this program, at least in this stage. So clicking next, we go into the sheeting and perf settings page. This has to do with if you want to add any sort of composite layup on the outside but still preserve the overall size of your airfoil, or if you want to change the perf settings, which essentially means the temperature settings for your wire. The perf settings should be calibrated and adjusted appropriately and should not require any change. If you're noticing that you're coming out with a significantly different size, then you can go and change these settings, but be very careful as you do so. And typically this is not the place that you'd want to change it. There's other locations that are more appropriate. Coming back to sheeting though, if I want to apply an upper and a lower sheeting right here of say 2 millimeters, that would say that I have a 2 millimeter thickness for my composite surface on the upper and lower surfaces. If I hit apply, you can see that it's shaved down my airfoil, so the foam will be the inner portion of that, and whatever composites that I put on the outside, or tape I guess, that'll expand the airfoil size out to my originally determined chord length. For again mine here, I'm not going to worry about that. I'm not going to apply any sheeting. Apply, make sure that's not there, and just move on. Under the spar list, Profili will code in for you a way to cut out holes for spars if you need structural reinforcement for your wings. Your tail surfaces don't always need this. Oftentimes they're small enough that the physical properties of the foam will be sufficient to maintain structural integrity. But for an example, I'm going to throw one of them in here because oftentimes your wings are the opposite where you do need a spar going in. So I'm just going to have one going through here, so I don't need to be creative with my name. I'm just going to call it spar, click add spar, and you can see that pop up. It gives me a default location. The spar type will be square. It'll be at the 30% chord at the root and 30% chord at the tip. If I look at the roots, there's my square spar. Tip, there's the square spar as well. You'll notice it gets bigger because my tip airfoil is smaller than my roots airfoil. So as I'm creating this, I'm thinking ahead and saying, this is only one half of my tail. The spar I'm going to create, I want to go through the entire tail so that it can help support both together, and I don't get that weakest point of contact here at my root. And so I want this spar to actually be flush. Furthermore, they're flat between both sides. Furthermore, the spar that I'm going to be using is actually a circle. So I'm going to go ahead and change that to circle in here. I'm going to say the diameter of my circle is, the default 5 millimeters, but I've measured that out. Say root and tip, okay, they're both set to a circle. I don't have a tapered spar, so I'm not going to leave that unchecked. And under wing plan, I'll come back and say, okay, again, I want this to be straight. So I'm going to say that I'm going to determine this based on, I've done the math beforehand. I'm going to say my X position, my distance down my chord, is going to be in millimeters instead. And if my X position is at 45, I like that because that's the thickest point of my airfoil for the smallest airfoil for my panel. I'm going to come back to my root and actually move this back to a distance of 95. And now that I have that plugged in, it does move it farther back of my wing. It's no longer the thickest portion, but this airfoil is larger, so it should be able to handle that. And if I look at my wing plan, that gives me a nice straight spar cut through my panel that I could have a spar that travels both through this panel and through a symmetrical one on the opposite side. Another thing to note here is that the hot wire needs to get in here somehow to cut this spar out. It will either do, by default, if you don't check anything else, it'll come up and over your block of foam and cut down into your foam from above to cut out this spar hole. If you want it to cut from beneath, and as it's cutting the airfoil, come up and cut this out. We would click downward hot wire cut with an extra vertical down path of say 5 millimeters. That would just mean that it'll go down a little bit farther into your foam to make sure it clears your airfoil and doesn't ruin the surface of your airfoil. So again, the default on this is the upward hot wire cut. I'm going to leave it on there for now. I will also mention that if you're doing an asymmetric airfoil, you can invert the way that the airfoil is cut so that it is cut upside down if you prefer one of these methods over the other, or if that helps with the placement of your airfoil within your block of foam. So moving forward, the next one is about lightning holes. The purpose of lightning holes is to remove material out of the center of your airfoil to reduce the weight of your wing. However, because of the reasons that I said just barely, where the wire needs to get in there somehow to cut these out, if I click, for instance, apply automatic generation, and it creates these sections for me of removed material, yes, that'll really decrease the weight of my panel. However, the wire needs to come in here and cut this top surface and then hollow out the center, meaning that structurally I only have this small member here at the bottom that's holding my wing together. Typically for foam I don't like that. There's ways that you can patch that up, but oftentimes if you apply glue and things in there, you end up making a wing that's heavier than what wing you started out with. So I'm going to go ahead and delete this. I will personally never use this if I am cutting a foam wing. I would only do it if I was trying to use this program to make one out of balsa, which is a whole other discussion for another time. So again, I'll just click past this lightning hole setting, ignore that, and here we get to making sure that you know what the size of your foam block is. Here I know that the thickness of my foam block, meaning from the bottom to the top, is 5 centimeters or 50 millimeters, and the size of the foam cutter that I'm using the right computer. And so that goes with the right foam cutter, which is the white one, as in the color white. The carriages are a white color, and those have these dimensions as shown here, where the distance between the left and the right carriages is 600 millimeters. If I go to the wing plan right here, I can see the distance from the left side to the right side is 600 millimeters. The distance in horizontal that the carriages can run is 400 millimeters. And the distance vertically up and down, so up and down this way, is 200 millimeters. So another thing that I want to look at right here is I'm going to look at my wing plan. You notice on this diagram there's a DX right here. That's saying that your foam block needs to be moved forward from the starting position of the wire to 10 millimeters or 1 centimeter. It's not very much, but it just gives you an idea of how far forward to move it. If you don't move it that far forward and your panel is only as wide or I guess as deep as your airfoil, then your hot wire is going to exit the front end of your foam block and not actually cut out the tip of your airfoil how you prefer. So make sure that the foam block you're using is as thick as you say right here, but then it extends out farther than what is required. Another thing you want to look at on this panel is looking at the root tip and the tip rib. You're going to be looking at its placement in the foam block. If I had a thinner airfoil or maybe a thicker block, I could preserve the material and cut multiple airfoils out of this by reducing the height of this down to say 15 and maintaining a small distance between the bottom of the foam block and my airfoil so that I can still preserve that shape, but try to see if I can have enough space to cut out another airfoil on this top. You don't want to pack them too tightly. You want to make sure, again, there's a little bit of a distance between there. Ideally, you have at least a half a centimeter to a full centimeter distance between the bottom or between airfoils. So here, I'm not going to have enough room to cut out another airfoil. I'm getting really close to the bottom as it is to try to make that happen. So I'll just put it back in the middle so that preserve plenty of spacing. So make sure it doesn't exit out the bottom or exit out the top of my foam block. And put it right in the middle for both the root and the tip. Again, if we were just looking at the tip here, if that was the thickest part of our airfoil, we could probably do something like 15, maybe even down to 10. And I'd probably make that a little bit thicker, but you can see I could probably fit in another airfoil if this was the thickest part of my wing right here. Last thing for this slide is for the wing plan. You come here to see your position of your foam block on your foam cutter. I've intentionally added in taper because if you've got what's considered a Hershey bar wing, or a wing that has no taper to it, this doesn't apply as much. But with a taper, the distance between the left carriage and the right carriage on your foam block matters. You notice that the wire is going to cut along this blue line right here, and if my foam block is sitting over here all the way to the left side, my root to airfoil is going to be longer than what my desired airfoil is. Same if I go on the opposite end of things, my airfoil will be too small. So I'm going to make a note of this. It's automatically put this right in the middle for me, where it's 153.95 millimeters from the left side. That's distance from left to the right, and then it's the same distance from the tip to the right hand side. We can move that back and forth if we want. I could say 200 and put those off centered. Make sure you know this value because you're going to measure the distance from the carriage, the pulley, to your foam block beforehand. So I'll leave that right in the middle because that makes it easier to eyeball, a lot easier to measure because I can measure both sides and make sure that's accurate. Another method you could try is having your foam block wider than your actual span that you want to cut, because then if there's any error of one side is too thick or too thin, you can then just truncate down to what your span